Okay, so ladies and gentlemen, today we are going to continue with the nomenclature of alkanes. So remember from the classification we mentioned last time, we said that we have aliphatic hydrocarbons, and these aliphatic hydrocarbons, they are having carbon to carbon single bond or carbon to hydrogen single bond. And remember, whenever you have single bond, it means that you have sigma bond. Then alicyclic alkanes. When we said alicyclic alkanes, it means that they are often chain and they have a general molecular formula of CnH2n plus 2 and contain only linear and branchings of carbon atoms, that is acyclic. They can either be linear, that is when we said linear, it means that they are in a straight chain, something like this. You'll see them in straight chain, something like this, or in a branch chain. When we said branch, it means that they have substituent, something like this. So alicyclic, it can be either straight or branch chain. Then they are saturated hydrocarbons. When you say they are saturated hydrocarbons, it means that they have the maximum number of hydrogen atoms per carbon. So the maximum number of hydrogen atoms per carbon are 4. So they are supposed to be 4. That is something like this. You see, if we have carbon like this, so they have the maximum number of hydrogen atoms. So you see, this is the maximum number of hydrogen atoms per carbon. Although you can have carbon to carbon, but what we are referring to here is the tetravalency. So you can have carbon to carbon single bond. So you can have something like this. Okay, hydrogen here also hydrogen, here also hydrogen. So you see that this carbon is having it attached to another carbon here, but what you need to understand here, still there are the tetravalent, 3 hydrogens and 1 carbon. So it means that there are 4 number of attachments to the central carbon. Then the next thing is cycloalkanes. So after alkanes, you also have cycloalkanes. The cycloalkanes are carbons joined in one or more rings. So they usually form a ring, that is something like this. You can have something like this. This is a ring. Or close. So cyclo, it means that they're in cycle. So cycloalkanes, that is, it means something like this, this is cycloalkanes, and their general molecular formula is CnH2n. So the difference between alkanes and cycloalkanes is that in cycloalkanes we have the general formula of CnH2n, while in normal alkanes we have CnH2n plus 2. So that is what I want you to understand, the difference between alkanes and cycloalkanes. Their general formula are different, and acyclic, they are often chain or branch chain, while cycloalkanes are cycle. So that is the two difference that exists between the two, and at the same time they have fewer hydrogen atoms than an acyclic alkanes with the same number of carbons. So you need to also understand this. There are this difference, that the number of hydrogen atoms in alkanes are 2 less than that of the cycloalkanes. That is why you see that in the formula in cycloalkanes there is no plus 2. It means that there is reduction of 2 hydrogen atoms. Okay. Then all carbon atoms in an alkane are surrounded by four groups. So remember I did this last time. Then they are sp3 hybridized, and at the same time they have tetrahedral structure with a bond angle of 109.5 degrees. So always you remember cycloalkanes with these features. There are three features. They are surrounded by four groups. They are sp3 hybridized and they are tetrahedral. And we also have different ways of representing organic compound. We have Lewis structure. So when we say Lewis structure, or if you ask to draw a Lewis structure of a compound, is always like this. And if you ask to write for the 3D structure, it's always like this. And if you ask to write the ball and stick structure of organic compound, you write something like this. So we have three, although it's not actually three ways, we have like four ways of writing or of representing organic compound. We have Lewis structure, we have 3D structure, we have ball and stick structure, and we have skeletal structure. How is the skeletal structure look like? Is something like this, something like this. So it means that in all these points you have carbon here, you also have carbon here, you have carbon here, here is also a carbon, here is also a carbon. So this is the skeletal structure. So you see we have how many carbon? We have like around 1, 2 here, we have 3, 4, 5, 6. It means that we have 6. So how do you call this? It's just a normal hexane. So this is the skeletal structure of organic compound. So also it applies to all other hydrocarbons. So it applies to alkanes, sorry, to ethane, propane. Look at it, they all have their 3D and ball and stick structure. So in propane and higher molecular weight alkanes, the carbon skeleton can be drawn in a variety of ways and still represent the same. So look at in this way, this is the lowest structure, but you will see that at this point all the carbon are in straight chain. For this one, all the carbon are in straight chain, and at the same time it can be bent, and they all represent the something. So that is why you have to understand that the carbon can be drawn in a straight chain or it can be in a bent form. So this is 3 here, 1, 2, so still 3 here, it's 3, and here is also 3, and they represent the something in naming. There is no any difference. So the bend in a carbon chain doesn't matter, it doesn't mean anything, it's something. Okay, so there are two ways to arrange 4 carbon atoms given 2 compounds with molecular formula CnH2n. So you see, this is, we are talking about butane. So look at the butane here. It can be in a straight chain, something like this, and it can have two constitutional, it has two constitutional isomers. The two constitutional isomers, it can be a normal butane, and this is the normal butane. This is our normal butane without any branching, and this is isobutane. Why do we call it isobutane? Is because we have branch at the central carbon, and the branch is methyl, and it is in carbon 2. So because it is in carbon 2 and the branch chain is methyl, that is CH3 is methyl, so you can name it 2-methyl propane. Look at this, 2-methyl propane, or you can call it isobutane. So this is the straight chain. The first one is the straight chain, and the second one is the branching. And you see that in the first one we have 4 carbon in a row, and the second one we have 3 carbon in a row with 1 carbon branch. So butane and isobutane are constitutional isomers, that is different compound with the same molecular formula. So their molecular formula are all the same, but the only difference is just the position of atoms that are connected. So you see constitutional isomers define a way the atoms are connected to each other. So constitutional isomers is an isomers that show the difference of the connection of the atoms among themselves. Okay, so now the next thing is how to represent or how to describe primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. So look at in case of the primary carbon, you will understand that the central carbon is only attached to one carbon. This is it only attached to one carbon. So because it's attached to one carbon, we call it primary carbon. And look at the secondary carbon. The central carbon, the one in bold, are attached to two different carbon, and look at the two different carbon, so we call it secondary carbon. And the tertiary carbon is the carbon that attach to three different carbon, while the quaternary carbon is the carbon that connected directly to 4 carbon atoms. So please try always to know the primary, secondary, tertiary, and quaternary carbon. So that is that. So you see, this is actually an example. So we have a compound like this. So in the compound, primary, secondary, tertiary, and quaternary carbon are described. So you see the first carbon here is CH3. So it means that it is only connected to one carbon, so that is why it is primary. And for the secondary is directly attached to two different carbon. This is the first carbon that is attached, the first carbon here, and the other carbon here. So that is secondary. So I think this is clear. Then so hydrogen atoms are classified as also primary, secondary, or tertiary depending on the type of atom, depending on the type of carbon atoms to which they are bonded to. So which one is the primary carbon? You see that the primary carbon is only one hydrogen that attached to a carbon attached to another carbon. But in the secondary, you see that you still have the hydrogen, but 2 carbons are attached to. And in the tertiary, we have 3 carbon attached to. So this is the difference between primary hydrogen and secondary hydrogen, as well as tertiary hydrogen. So the maximum number of possible constitutional isomers increases dramatically as the number of carbon atoms in the alkanes increases. Yes, of course, remember, as the number of carbon increases in an alkene, the more the number of the constitutional isomers. So it means that butane have two constitutional isomers, while we expect pentane to have more number of isomers than butane. And also hexane will have more number of isomers than the butane. So that is how it is. So like for example, look at in 10 carbons, that is the kene, there are 75 possible isomers, while for the carbon 20 there are possible constitutional isomers of 366,319. So the suffix an identifies a molecule as an alkene. So whenever you have ane at the end or as a suffix of a compound, it tells you that that compound is alkene. So also at the same time, by increasing the number of carbons in an alkane by a CH2, that is methylene, one obtains a homologous series of alkanes. Yes, remember we told you last time that homologous series is the series in which each individual member of a particular family is increased by CH2. So as you increase the CH2 in a particular compound, and then CH2 is known as methylene. It's known as methylene. So now look at this. This is normal alkane, so it's a straight chain normal alkane. Look at them. We have 1, 2, 3. So for carbon 1, 2, and 3, they doesn't have any constitutional isomers. They have 0 constitutional isomers. So we can decide to ask you, among the following compound, which one doesn't have constitutional isomers? So any alkane having less than 4 carbon, it means that they can undergo constitutional, sorry, it means that it will not undergo constitutional isomerism. So look at butane have 2, pentane 5, heptane 9, decane 75. Okay, so and then the next one is cycloalkanes. So cycloalkanes have molecular formula CnH2n and contain carbon atoms arranged in a ring. So their carbon atoms is arranged in ring. So simple cycloalkanes are named by adding prefix. So for the cycloalkanes, you need to add prefix cyclo, the name of the acyclic alkenes having the same number of carbon. So look at it. If we have 3 carbon, so instead to call it, so you see this one all are represented in ball and sticks. So instead to call it propane, so it is now cyclopropane, cyclobutane, cyclopentane, and cyclohexane. So it's simple. If they have 5 carbon, so it's cyclopentane. If they have 3, is cyclopropane. So you cannot just call it as propane because it is in cyclic form. So you name it cyclopropane. So now nomenclature. So if you are trying to write the nomenclature of organic compounds, always you have to put 3 things at the back of your mind. Number 1, prefix, parent, and suffix. So the parent name, when you said parent name, it means that the carbon or the chain with the longest carbon chain, with the longest continuous carbon chain, while the suffix indicates the functional group that is present, while the prefix tells us the identity, location, and the number of substituents attached to the carbon chain. And I think we did this, so it means, let me just give some demonstration here. Like if we have something like this, 1, 2, 3, 4, 5, 6. So this is the, or I can have something like this. So you can count the number of carbon. If you start, remember that I told you previously that bending, it doesn't matter. So you can start counting from here to say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It means that if you follow this direction, the longest carbon chain is 5. But if you follow this direction, 1, 2, 3, 4, 5, 6, you see that the longest carbon chain is 6. So we'll now go with 6, not the first one with 5. Is that clear? So that is this. Then that is a parent chain, and the suffix is the functional group. So because all the carbon to carbon bond is single bond, so it means that the suffix will end with ane, so it's alkane. And the prefix depend on the number of the constituents. The constituent, like for example, if we have something, so this is the constituent. If we have something like this, so it means that this is our constituent, that is a branching. Okay, so nomenclature: carbon substituents bonded to a long carbon chain and are called alkyl groups. So they are always considered as alkyl groups. An alkyl group is formed by removing one atom of hydrogen from an alkane. We did this. To name an alkyl group, change the ane ending of the parent alkane to alkyl. So if we have methane, when you remove one hydrogen, it becomes methyl. When you have ethane and you remove one, it changes to ethyl. So naming 3 or 4 carbon alkyl groups is more complicated because the parent hydrocarbons have more than one type of hydrogen atom. So propane has both primary, secondary hydrogen atoms, and removal of each of these hydrogen atom forms a different alkyl group with a different name. So notice, like for example, look at if you remove the primary hydrogen, it becomes propyl group. But if you remove the secondary here in the compound, then it now changes to isopropyl. So always, if propane come as a substituent, always know that is it that it is iso profile or normal profile. So you can only know that by knowing which of the hydrogen atoms is removed. Is it the primary hydrogens or secondary hydrogen? Okay, now rules of naming alkanes. So we are going to look at the rules of naming alkanes, and these rules, we have number 1. So the first thing is to find the parent carbon chain and add the suffix. So you see the first one here, look at how they are colored. You see that in the first one we have the counting, we have 8 carbon atoms, so we name it octane. While the second one, if you count it in the bent direction, we have 7 longest chain. So between 7 and 8, which one is the longest? The one with 8. So that is why it is correct, while the one with 7 is incorrect. So whenever you are given a compound, always count it in different directions so as to know which of the chain direction have the longest carbon chain. And it doesn't matter if the chain is straight or it bends. I did this last time. Then look at another one. You see that the longest carbon chain is 8 carbons. So you see they are counted in different directions. This one is counted in a straight chain direction, and this one in a bend direction, and this one in a bend direction, something like this. So you can count in different directions, but what is the most important is to know the longest carbon chain. Then if there are 2 chains of equal length, pick the one with a greater number of substituents. Example, two different longest chain of the same length. You see we have substituent here, we have substituent here. So you see we have two different substituents, while the second one, look at the way it's the direction. Although all the carbons in all the direction there are seven longest chain, but the one with more substituent is the first one. That is this one, because there are two different substituents and this one have only one substituent. So because of that, the one that follows the direction of two substituents will be considered correct, while the other one will be considered incorrect. That is if in the case where you have the number of carbon in all the directions are the same, but always the length of the carbon supersedes the number of the substituent. So if you have like the one with, let's say, 9 and the other one with 7, or let's say 8, but the substituent, let's say they have 5 substituent and the other one with 9 has 3 substituent, but because of the longest chain are 9, so we'll take the one with 9. So the substituent that you doesn't consider the number of the substituents. Okay, so number the atoms in the carbon change to give the first substituent the lowest number. So it is also very important when you are naming to look at the position and the number of the substituent. So when you count them, the one with the lowest number of the substituent will be considered. So let's look at the first one. The first one, you see that the carbons are numbered 1, 2, 3, 4, 5, 6, 7, 8. So look at it. At carbon 5 we have substituent ethyl. At carbon 2 we have substituent methyl, because it's only one carbon, it means methyl. With the one with 2 carbon, it means ethyl. So now we take them, we add them, we see which one have the lowest number. So the one with the lowest number will be considered. So at carbon 2 we have, at carbon 5 we have, then at carbon 6 we have, and let's look at this one. At carbon 7 we have, that is this one, and at carbon 4 we have, and at carbon 3 we also have. So what we are going to do, we add these numbers to see which one will give us the lowest. So 2 plus 5 we have 7, 7 plus 6 we have 13 in total, and this one 7 plus this we have 7 plus 4 we have 11, then plus 3 we have 14. So you see this one is 13 and this one is 14. So this one is the lowest, so that is why this one is considered as correct and this one is wrong. So if the first substituent in the name distance from both ends, so number the change to give the second substituent the lowest number. So example, given the lower number to the second substituent, so what it means here is, if you number the carbon, look at the first one, we have 1, 2, 3 and 5. So at carbon 2 we have, at carbon 3 we have, at carbon 5 we have. But if you number it from the other direction, that is 1, 2, 3, 4, 5, 6, so you see that the methyl here, the lowest number will be if you follow it in this direction. If you follow the counting from this direction. When we say this direction, it means if you follow it in this, and if you follow it in this, you will see that the number is higher. But let's count it. Let's follow the other way. You see, if you follow it in this direction, when you count, you see that you have 1. Okay, at carbon 2 you have, at carbon 3 you have, and at carbon 5 you also have. This one is incorrect. So also, if you count it in this direction, you have it at carbon 2, you have it at carbon 4, and you also have it at carbon 5. So 2 plus 3 we have 5, then we have 10. So this one is lower, and this one, if you count it to 2 plus 4 we have 6, we have 11. So this one is 11. So if you count it in this direction, the number is higher, and if you count it in this direction, the number is lower. So that is why this one is correct and this one is wrong. Then when numbering a carbon chain result in the same numbers from either end of the carbon, assign the lower number alphabetically the first substituent. So the two different groups equidistant from each angle, so it means that they have equidistant. So why do we say that they have equidistance? If you count them, you will see that you have the same number. So if you have the same number, what do you supposed to do? So look at this one. If we follow this direction, we have 1, 2, 3, 4, 5, 6. So at carbon 2 we have ethyl, then at carbon 5 we also have ethyl. So here we also methyl, 1, 2, 3. At carbon 3 we have 1, 2, 3, and at carbon 5 we have, okay, no, here we have 1, 2, 3. So it's 3. It's at 3 we have ethyl, and also here at 3 we have methyl, and at carbon 5 we have ethyl. So now if you now look at it, you will see that ethyl is at carbon 3 if you follow this one, and methyl is at carbon 5, the same in the same direction. But at this point, methyl is at carbon 3 and ethyl is at carbon 5. So you see that the number are all the same, all are 8, 8. So if you have something like this, what do you supposed to do, or which one do you supposed to take? Then you follow the lower number and also alphabetical order. So now between methyl and ethyl, which one supposed to come first? Is ethyl, then followed by methyl. So now what I want you to understand is the ethyl is at a lower carbon in the first one, while the ethyl is at carbon 5 in the second direction. So therefore, because ethyl comes first and it is lower for this one, for this compound, so that is why it's considered correct and this one wrong. Then the next thing is name and number the substituents. You name them and you number them. Name the substituent as alkyl groups, and each carbon belongs to either the longest chain or a substituent, not both. So each substituent needs its own number. Yes. And if two or more identical substituents are bonded to the longest chain, use prefix to indicate how many. If there are two, you say di. If there are three, tri. If there are four, tetra. If there are five, penta. So now look at this one. We have methyl at carbon 2, we have methyl at carbon 6, and we have ethyl at carbon 5. So we give them their own number, and the longest carbon chain is is octane. So you can simply name this. You can say 2 methyl, because at carbon 2 we have methyl. So yes, because you have methyl, so you cannot say 2 and 6 are differently. You can say just 2 comma 6 methyl. We have ethyl. So you can see in alphabetical order, we follow it in alphabetical order. You say 5 methyl, 5 ethyl, comma, hyphen 5 ethyl, hyphen 2 comma 6 hyphen then methyl octane. So combine substituent names and the numbers plus parent and suffix, then precede the name of the parent by the names of the substituents. Alphabetize the names of the substituent, ignoring all prefix except iso, as in isopropyl and isobutyl. Precede the name of each substituent by adding the number that indicates its location. Separate numbers by commas. So if you have numbers, so you use comma to separate them, and separate numbers from letters by hyphen. So between numbers and letters are separated by hyphens. Then the name of alkane is a single word with no space after hyphens and commas. So now identify all the pieces of a compound using steps 1 to 3. So now look at it. At carbon 2 we have methyl, and at carbon 6 we have methyl. So that is why we have 2 6 dimethyl, because we have methyl here and we also have methyl here. So that is why we said 2 6 dimethyl. And also at the same time we have ethyl here at carbon 5. So because of this, we have at carbon 5 we have ethyl. So ethyl comes first in alphabetically, so E comes first before M. So that is why we have 5 ethyl 2 6 dimethyl octane. That is the name. Then what for the cycloalkanes are named by using similar rules, but the prefix cyclo immediately precedes the name of the parent. So the parent always come as cyclo. So prefix plus cyclo plus parent plus suffix. So look at this one. We have 6 carbon in this ring. We have 6 carbon. We have 6 carbon here. So that is why it is cyclohexane. And there is also substituent. This is a substituent, and this is also a substituent on its own. So we'll see how we name this. So name and number the substituent. No number is needed to indicate the location of a single substituent. So you see because here it is a single substituent, so there is no need to number it. You can just say methyl cyclohexane, but if the substituent are two, then you can do that. So now look at another one. The carbon is tertiary here. The carbon is tertiary because three different carbon are attached to the carbon, so it's tertiary. So that is why it's tar butyl cyclopentane. So for rings with more than one substituent, begin numbering at one substituent and proceed around the ring to give the second substituent the lowest number. So look at this one. So if you number the methyl first, 1 2 3 4 5 6. So at carbon 1 we have methyl, and at carbon 2 we also have methyl. So the name is 1,3-dimethyl cyclohexane. But if you follow the other one, if you follow the anti-clockwise direction, we have 1 2 3 4 5 6. So at carbon 1 we have methyl, and at carbon 5 we have methyl. So we have 1,5-dimethyl hexane. So which one have the lowest number? 1 plus 3 we have 4, and 1 plus 5 we have 6. So the one with lowest will be considered correct. Therefore this one is correct and this one is wrong, because this one give you 6 and this one give you 4. Then with two different substituents, number the ring to assign the lower number to the substituent alphabetically. So if we have more than one substituent and they have different substituent, and those different substituent you count them and you give them the lowest number. So we see here at carbon 1 we have ethyl, and at carbon 3 we have methyl, and the other one, methyl is at carbon 1 and ethyl is at carbon 3. So ethyl always comes first, so you will take the ethyl with the lower number. So that is why we have 1 ethyl 3 methyl cyclohexane as the correct one, and the other one is wrong because the methyl is at carbon 3 and this one, the ethyl is at carbon 1. So in case of an alkane composed of both a ring and a long chain, if the number of carbons in the ring is greater than or equal to the number of carbons in the longest chain, the compound is named as cycloalkane. So it means that in a situation where you have the okay. Sorry for the disturbance. Okay, so now that is, if you have alkanes and cycloalkanes, the number of carbon change is the same as the cyclo and the substituent. So always the parent names goes to cyclo. So now look at this. We have contrast two different examples. More carbons in the ring, so 4 carbons in the chain. So a butyl, so 6 carbon in the ring, So this one is just straight. So this one is butyl cyclohexane. But look at the other one. We have 4 cyclo, that is 4 ring, and we also have the number of carbon chain is longer than the cycloform, so that is why it is going to be the butyl here, or the cyclobutane will now come as a substituent. So it is now going to be at carbon 1 we have cyclobutyl, so 1 cyclobutane butyl hexane. So all this it applies to all of them. You see this one, we have ethyl here, we have ethyl, we have also ethyl at 3 different positions. So that is why here we have we have 1 2 3. Look, this one we have 1 2 3 triethyl cyclopentane, and this one we have 1 2. So all this is just the continuation of the naming, and this one is ethyl cyclobutane. Physical properties of alkanes. So we are going to continue from here.